Hello, my name is Professor Shams. I'm going to be teaching you how to find the whole and identify the vertical asymptote as well as the slant asymptote. So, this is my function, x minus 2, x plus 2, x over x plus 4, x minus 2. The first thing we want to notice here, the first thing we want to identify is our whole, and that's when we see a common pair like x minus 2. So we can just cross that out, and we should write whole is positive 2. That's our whole. The next thing we want to look for is, so that is the x of our whole. Now we want to find the y of our whole. So the way we do that is we plug this into our equation. So we're not going to plug it into the things that we took out. We just plug it in to x plus 2, x, and then x plus 4. So we have 2 plus 2 times x over 2, this marker's bad, 2, plus 4. Okay, 2 plus 2.
Professor Shams.
Yep, thank you.
Yep.
Good call. 4 times 2
Should probably move.
over, I will, 6.
But
So
we
this
can't
is also,
see you doing the
This is
problem.
also a horrible marker, so I'm going to switch.
Purple is the best.
The purple is. Purple and green Joker color. I like it. So now we have 4 times 2 equals 6. This, oh yeah, this is great.
Equals 8.
4 times 2 over 6. And now what we're going to do, student, is multiply these, which you get 8 over 6. That is our y. So now what we're going to do is now we have our whole, the coordinates of our whole. This is also, if you want to make it easier to visualize, you can make it into a mixed number, which is 1 and 1/3. So our coordinates for our whole are 2 and 1 and 1/3. Okay, so now we go to our beautiful graph that I use a ruler to make. And we go to 2 and then 1 and 1/3, which is somewhere like, say there. And we draw an open circle for whole. Okay, so now that we have our whole, so the first thing we wanted to identify, we now want to go on to our vertical asymptote. So the vertical asymptote is on the bottom. It's right here. So since it's x plus 4, the solution to that is negative 4 plus 4 equals 0. So our vertical asymptote is negative 4. VA equals negative 4. So now that we have that, we have our vertical asymptote at negative 4. Just going to fix my points real quick so we have more room. So our vertical asymptote is right here at negative 4. Cool. So now we want to test values near our vertical asymptote to figure out whether it's going to be going up or going down. So that way we do that is we pick one to the left and one to the right of the vertical asymptote. We're going to start with negative 3. So negative 3, we now plug that in to our equation. So what we do is, if you can see over here, negative 3 plus 2 times negative 3 over negative 3 plus 4. Negative 3 times 2 is negative 6 times negative 3 over negative 3 plus 4 is 1. So now negative 6 times negative 3 is 18 over 1. So that is positive. So now, now that we have that, I'm sorry. Hold on. No, it's fine. It's the same thing. So now it's positive. It's positive. Can you stop?
Sorry.
Can you stop, student? I know it's going up. So now that we have a positive number, we know that over here it's going to be going up. So now that we know that, we want to plug in negative 5, which is on this side, figure out where it's going over here. So now we're going to plug in -5. So, yep, okay. So -5 plus 2 times -5 over -5 plus 4. Cool. -5 times 2, or plus, that's what I did.
Yeah.
-5 minus 2, or plus 2 is -3, times -5, that's positive 15, and then this is -1. So we get a positive 15 over a -1. So now what we get is -15. So since this is negative, we now know that this is going down on this side. And just a correction over here, what I did is I accidentally multiplied these instead of adding them. So in reality, this comes out to 3 over 1. Cool. Okay, so now that we have that, and we've identified our vertical asymptote and which way it's going on each side, now we want to shift to the horizontal asymptote. So the way we look at our horizontal asymptote is the degrees of the top and of the numerator and the denominator. So since we have 2 x's up here, you can either count the whole or not. We're going to choose not to. So up here, it's x squared, because we have 2 x's, and down here, it's only 1x. So the degree is 1 greater on the numerator than it is on the denominator, which means we're going to have a slant asymptote. So the way that we find a slant asymptote is by using long division. So we divide this, or do we divide? Yeah, so we divide our top by our bottom. So the way we do that, I'm going to erase some of this stuff. Actually, I'll just do it over here. So our equation we set up for our long division.
We can't see it.
Yeah, I know. That's why I'm going to move in 2 seconds if you're a patient cameraman. Okay, so this is our equation that we set up. So the way that we solve this is, how do we get x squared? We just add an x. So this becomes x squared plus 4x. So these cancel out, get -2x. And then so now how do we get to -2x? Multiplied by -2. So we get -2x, -2, which is -8. And then subtract those, so those cancel out, so we have nothing, and then this is just a positive 8. So this is our remainder, but the real thing that's important here is right here. That is our slant asymptote. So since it's x minus 2, it's our slant asymptote is positive 2. So right here is positive 2. So our slant asymptote is going to look something like this. Cool. So that is what our slant asymptote is going to look like. And then the last thing that we want to do is find our x-intercepts. So our x-intercepts are right here. So one x-intercept is 2, or -2. So, and what we're going to do is we're going to set these to 0 just to make it easier. So when we set it to 0, that's an x-intercept. And then when we set our other one to 0, which is just x, it's 0. So those are our 2 x-intercepts. So those are the points that we want our line to go through. So now what we're going to do is, since this is going to be going up, the way this is going to look is you bring your line down, has to go through -2, and then it's going to bounce back up through 0, and then it's going to follow our slope, or our slanted asymptote. And the thing about our asymptotes is that they are going to become very close to the asymptote, but they're never going to touch. This is a poor representation because I'm not great at drawing, but as this goes out, it's just going to get closer and closer to the slant asymptote, but it's not going to hit it. And so when the slant asymptote really matters is not really in the middle of our graph, but more towards the end when the x gets very large. So yeah, that's how you solve this equation.